All right, hello everyone. Welcome to our last video in this equations topic. And our final video and little subtopic here we're doing probably gives students the most trouble in my experiences. So we'll try to go through this quite slowly and just give you an idea of how to do these types of questions and how to actually build up equations from these worded problems. That's kind of all we're doing in this video. We are interpreting the sentences we're given, we are getting the main information out of them, and then we're trying to set up equations and solve them. So a lot of students can kind of do this via trial and error and just sort of seeing something quickly and plugging in the numbers and checking it. But I just want to give you hopefully a good grasp on actually setting up the equation here, because as these get harder in later years, as you get more information, as the questions get more abstract, we need to really build up this skill of finding the important information, setting up an equation, and then solving. So I have a question here, which is, when Kate adds her current age and her age next year, the result is 19. How old is Kate now? Okay, so I'm going to lay out a couple of, well, at least some important steps we need to take when solving these types of equations. So first of all, we want to underline the key information. Key info. Cool. Okay, so we are adding, well, I'm going to highlight it here, we are adding Kate's current age and her age next year. And when I add these together, the result is 19. And we're asked how old is Kate now? So we want to find her current age. Now, equations help us to find unknowns. They help us to find unknown pronumerals. So let's make one of these bits of information, or more specifically, the bit that we want to find, let's make that our unknown that we want to find. So step 2, we are going to set a pronumeral. Some of you just may know this as a letter for the unknown in the question. So, what do I mean by that? Well, I want to find Kate's age now, her current age. So I'm going to say, let X be, let's just do it, let's do an A for age. So let A be Kate's current age. So when I set up my equation, I want to use an unknown number because I want to try to solve this equation. So I'm going to take these bits of information and assign a letter to them. Now, I'm told that she adds her current age and her age next year, and the result is 19. So let me write that actually in words quickly. So that means her current age next year age. And we say the result is 19. So I'm going to put equals 19. But we have come up with a pronumeral for Kate's current age. So we can substitute that into here. So her current age, we said, let's call that A. Okay. So what's her age next year going to be? Well, a year has passed, so your age has gone up by 1. So her age next year, we can write, well, we're adding her current age to her age plus 1 year. Now, this is a pretty important idea that I'm hoping we can pull out from this. Once we set a pronumeral for one piece of information, so for example here, the current age, we can use this pronumeral to set up the other information still in terms of that same pronumeral, because this is going to allow us to use some of the skills we've been doing up until now. See how both of these things are expressed in terms of A. I have A and then one more than A, so A plus 1. Now this equals 19. Now, sorry, let me move my next question down. I didn't think I'd use this much space, but that's okay. Oops. Let's move that down to there. Okay, so what does algebra tell us? Well, because equations apply some of the ideas we we're talking about in algebra. Because look here, we have, let's do a different color. We have like terms. We have an A and an A. So when we write A plus 1, when I add my like terms of A and A, what am I going to get? Well, algebra tells us that I'm going to get 2A. And my plus 1, I can't do anything with that to simplify it all. So I just have to leave that as 1. So I've added my like terms here by setting up my equation and then substituting in the pronumeral we made for Kate's current age. We can write an equation in terms of A and then simplify it using algebra. And from here, I can solve my equation. So I have 2A plus 1 equals 19. Now, by now, I hope we're all comfortable with solving these systematically. So 1 is added to 2A to give me 19. So 2A must be 1 less than 19. I'm going to do that to both sides. That's going to leave me with 2A on the left. And on the right, I am left with 18. So, very last step, I can divide both sides by 2 because I'm saying, whoops, sorry for the typo, that's meant to be an equal sign here. So when I subtract 1 from both sides, I get 2A equals 18. We want to find what number multiplies by 2 to give me 18, which is the same as finding what 18 divided by 2 is. See, we're always doing the opposite operation. There's a multiplication implied up here. So we can divide through to leave us with just A. Now, I get A equals 9. And A, we said, was Kate's current age. So we have solved the problem. We have found how old Kate is now, what Kate's current age is. And that is A equals, well, that is 9. So her current age is 9. And we can double check that because her current age plus her age 1 year, her age next year, 9 plus 10 gives me 19. So we can always substitute back into the original equation just to make sure what we found is correct. And you'd probably especially want to do this for worded problems because there's a lot of information, a lot can go wrong. So I would always recommend trying to substitute back into the equation. But let's try one more here. So we're given that Jonas is paid $17 per hour and gets paid a bonus of $65 each week. And one particular week, he earned $643. And I realized I've forgotten to copy in the next part of this question. So I'm going to write this in here. Let's just add how many hours did Jonas work this week? There we go. Okay, so now we have the full question. Sorry about that. So once again, what I'm going to do is I'm going to underline the main points in this question. So I get $17 per hour. So that means every hour I get $17. So for 1 hour, I get 17. For 2 hours, I get 2 lots of 17. So $34. For 3 hours, I get 3 lots of 17, and so on and so forth. That's going to be important in how we set up our equation. And he gets paid a bonus, so an additional amount of money of $65 each week. So one particular week, he earned $643. And our question is, how many hours did Jonas work this week? So I'm going to, now that I've underlined everything, I want to set a pronumeral for the amount of hours Jonas worked that week. So I'm going to say, let H be the hours Jonas worked. Cool. Okay, that's what I'm going to be solving for, because remember, equations help us to find these unknowns. So, okay, he's paid $17 per hour. So he gets paid $17 each hour. So to find his pay for H hours, I just take that as 17 lots of H. Because we said before that if you were to work 2 hours, we could find this by timesing 2 by 17. If you worked 3 hours, I could find this by multiplying 3 by 17. So if he worked H hours, I can find that by multiplying H by 17, which I can write in the sort of shorthand algebra way we learnt a while back as 17H. And Jonas gets paid a bonus of $65 each week. So that means that no matter how many hours he worked, he always gets $65 on top of that. Now, how can I write on top of that as in maths terms? Well, I have my 17H, my $17 per hour, and another $65. So I'm adding 65 to this. I have $17 for each hour, and I'm adding $65 to that. It's a $65 bonus. So whatever I make plus 65. And that particular week, he earned $643. So I have substituted, I've put in my 643 to equal this thing here on the left-hand side. Because of that, now I can solve to find my hours worked, my H. Okay, so now here we can solve the equation systematically again. So 17H, I'm adding 65 to it. What was 17H before I added 65? That's going to be 643 minus 65. So I got 643 when I added 65 to 17H. So 17H is going to be the difference between 643 and 65. So I'm going to minus that from both sides. I'm doing the opposite of this plussing, remember? So what's that going to leave me on the left-hand side? That leaves me with 17H. And on my right-hand side, I'm going to get 578. 578. Cool. I'm very close here. Sorry, that's a bit of a gap I've left here, isn't it? Okay, 578. Cool. We're almost there, guys. Bear with me. If you already know how to do this, that's fantastic. By now, I'm hoping we all have this, we understand how to approach solving these systematically. The hardest part about these questions is getting the information and setting this thing up. Once we have that, we can do what we've been doing this entire time. What gives students a lot of problems is they can solve it systematically. They just struggle with setting up an equation here. So I'm hoping that this is sort of giving you a good introduction into how we'd go about this. But now that I get here, there's one more thing I need to do, and that is I'm multiplying h by 17, and that gives me 578. So I can find h by dividing both sides by 17. I'm timesing here, so the opposite to that is dividing by 17. That's going to leave me with h. And when I divide 578 by 17, I get 34. So because my thing that I set to h is the hours Jonas worked, then by finding this h, by finding this unknown, I have answered the question. I've found how many hours Jonas worked in order to make $643 because he gets 17 per hour with an additional 65 on top of that. So once we set this up, solving the equation just gives us that unknown. Now, as I said before, the hardest part, guys, about these types of questions is just making sense of the wording. The wording throws a lot of people off. But if you just get into this habit we talked about before of underlining the key info, setting a pronumeral or letter for the unknown in the question, and then setting up this equation and solving the equation, we once again have a systematic way. We have this system towards solving these worded questions with what we know from equations. Now that sums up the topic so far from the Year 7 syllabus, which I'm going through. Thank you so much for joining me and have a great day.